Goa was the first part of India that was colonized by Europeans and also the last to be liberated. The Portuguese set up a base in Goa in their quest to control the spice trade. When India became independent in 1947, Goa remained under Portuguese control. Under Indian rule, Goa has become an autonomous, federally administered territory. Goa was admitted to Indian statehood in 1987. The 400-year-old Portuguese time construction of Raj Bhavan Palace, the official residence of His Excellency, the Governor of Goa, is situated atop the Cabo Promontory at the confluence of rivers Mandovi and Zuari. The Cabo Hill, which rises to an elevation of nearly 15 meters above mean sea level, has a plateau at the top, and the Raj Bhavan, situated at the westernmost tip of the plateau, faces the Arabian Sea. The construction of the palace dates as back as to 1590. The northwestern and western slope of Cabo Hill, adjacent to Raj Bhavan complex, has been experiencing a continuous process of settlement and distress since decades. As a result, cracks have been developed on the pavements, floor of the veranda, and intercepting the western and northwestern part of building of the historic palace and Raj Bhavan. The problem was studied earlier by different scientific agencies. A number of remedial measures was undertaken to safeguard the building by stabilizing the slopes. All these measures have failed to achieve the purpose, thus promoting the state authorities to approach GSI for rendering expert advice in safeguarding this historic, prestigious Raj Bhavan Palace.
Cabo Raj Bhavan is the official residence of the Governor of Goa, and as is widely known, it is a monument of great historical and architectural relevance. It's a 400-year-old building located on a cove jutting into the Arabian Sea, which is surrounded by forest on three sides. However, for the last about 3 decades, as I've been told, there were some cracks which were developing on the slope, and the cracks were surfacing also, and we could see cracks in the balcony and also in the veranda areas on the tarmac. So it was at that time that there was serious concern about the stability of the whole structure, and also there was a need to take efforts on how to maintain the structure and also to keep it viable as the future residence of the governor to continue.
I must say that all the governors have shown keen interest, and they had given instructions to the office to take whatever action that was required to see that this piece of heritage in Goa is protected, preserved and well maintained. Coming to the problem of settlement which has been taking place behind the palace, including the surface and the veranda, the irrigation department, now known as the water resources department, has been taking various remedial measures. As and when any problem occurred, we immediately brought it to the notice of the department, and I must say that the department has been very alert and very enthusiastic in assessing the problem and taking remedial steps. I think the work has been going on in smaller measures from 1970s or so, and it was in 1995 that a serious effort was made to see that the settlement problem is fully stopped or arrested. I think the CBRI, the Central Building Research Institute, Roorkee, was involved in the study of the problem, and they submitted their report, and their recommendations were also implemented by the irrigation department, the water resources department. Sometime in 2002, there was a major problem behind the Raj Bhavan. It that a portion of the hill went down, settled down, and we could see huge cracks. There is a parapet wall from which the land behind went down by 1 meter or so. And that was the major problem which we had ever seen and it evoked serious concern from all of us. Of course, the governor also, the secretaries also, and the engineers as well.
We have so many agencies, renowned agencies associated with these problems, right from Mr. M. Manohar, who was the beach erosion director, member of beach directorate of Ministry of Water Resources. We have the IITs associated with it, we have the CBRI associated with it, we have lot many renowned agencies which have been associated with this problem. There have been so many measures suggested which have also been executed, and presently at last this problem was pushed to Geological Survey of India.
A suggestion came from the governor himself that the Geological Survey of India could be involved in this. Accordingly, the Geological Survey of India was entrusted with this work by the irrigation department. They came, made a serious study of the problem, and they submitted a comprehensive recommendation, and that recommendation has been implemented by the Water Resources Department. They have undertaken a major work. I think the first ever major work which was done about 2 years ago. They have successfully completed it, and it is hoped that this major work would protect this hillside and the building for many years to come.
Geological Survey of India have envisaged some measures, some innovative measures, I would say, basically which involved anchoring of these slopes and this top cap to the soft strata by giving it by increasing its shear carrying capacity by hardening it, and this anchoring was a very technically intrinsic work which I think we have executed to the core and to the T. So it was a challenge to the department, and I am proud to say that my engineers and my whole team has worked day and night to see that this project is successful.
The Water Resource Department of the Government of Goa had entrusted the work of analyzing the unstable slope at Kaboraj Niwas to the Geological Survey of India. The Geological Survey of India along with the staff took up the work of investigation of the unstable hills in the year 2003 and conducted the investigation by drilling of bore wells, collecting the sand samples of the soil and also knowing the texture and type of slopes available at the site.
We are standing at the backdrop of the seat of His Highness, His Excellency, the Governor of Goa, and this the backdrop, and this is about 100 meter away from the seashore, and it's about 40 meter above the sea level. Now this area has been under threat from the distress, the natural distress, the movement of the Mars down below, and this is moving on towards the sea. And this movement of the Mars towards the sea, it has caused number of manifestation on the ground, and see here number of cracks and so many things are developed, and these cracks have started from there and has entered into the building and far away from the interior of this the building. So with this problem in hand, so this Governor of the Goa, he requested Geological Survey of India to take up this investigation. At their instance and also on the request of the WRD, Government of Goa, Geological Survey of India took this the investigation in hand. Yeah, this investigation was taken up in the month of June 2003, and Mr. Panduranga, Mr. Dharuman and myself, we were all involved in that. This team of experts, we came over here, and first of all we mapped all those cracks and the surface manifestations which were existing and what you have seen on the ground. We could identify 3 active slide zones over here, zone number 1, zone number 2 and zone number 3, and this is where we are standing is zone number 1, where the most sliding is taking place, and the very highly sensitive distressing has taken place in this area. This area, when we see, this is the one about 10 meter thick zone is there, which is having the laterites. There we call it as a duricrust. This is the hard material, and down below we have got only the soft material, only the soil available here, which is more than 30 meter thick on the surface. We don't know at what level the soil is continuing below the sea level. So then in the first phase we mapped all these things, and we suggested that this is the area which needs a constant the study and also an exploration. So this first phase report was submitted to the to His Excellency the Governor of Goa as per the schedule within 30 days of our commitment. Later on, after getting a good impression by the Governor of Goa, and we took our second phase of investigation, which was thoroughly a package of investigation. It is a full package. The package, this includes geotechnical mapping over here, and also this ground survey, which has to give this the contours and everything. That's the topo mapping. Then geophysical surveying, geophysical mapping, just to know the bedrock profile and also the variations in the soil composition. Then drilling, subsurface drilling, just to know the different lithological changes what we are finding beneath the surface, and also to know the groundwater level down below, and also to know the extent of configuration of the slip circle what we have identified.
Based on the recommendations of the GSI, the department has taken up the implementation of the work through ITD Cementation India Limited, who are the experts in such type of works. Total cost of the work was to the tune of 617 lakhs. Major component of the work are stabilization of upper slope by pre-stressed cable anchors, which are anchored into the hard strata with a stress up to 25 to 30 tons. Middle slope by providing vertical RCC piles with RCC cap for a length of 240 meters. The lower slopes are stabilized by providing concrete walls to intercept the slip circle. Also, the toe of the heel is protected by providing concrete blocks to avoid direct effect from the sea waves. The work was executed by the department guidance and supervision of the GSI Bangalore, who were all along associated with the implementation of this project.
Our second phase of investigation, it was a total teamwork between Geological Survey of India and the WRD engineers, and they were thoroughly associated with we people. And while drilling, our aim was not just to see the configuration of the soil, and also to know the different physico-mechanical or engineering properties of the soil. So for that, we did in situ testing over there. That in situ testing includes the determination of the N values by SPT test, collection of the undisturbed samples over there, collection of the disturbed samples, and take all these samples to the laboratory, get them properly analyzed for, importantly, to collect the CN5 values, moisture content, density factor, everything, which are certainly required, which are essentially required to work out the stability parameters of this distressed slope.
Based on the analysis of the whole data collected, they have recommended the remedial measures to be taken up in order to stabilize the slopes such that the cracks and collapses which were occurring regularly do not occur henceforth. The remedial measures suggested by the GSI could be analyzed into 4 parts or divided into 4 parts. This is the cladding wall which was there. These are the proposed anchor bores, and this is the slip circle, and these are the inclined piles. From this point to this point is called as a middle slope, and this is called as a middle slope, and this is a slip circle. These are the factor of safety lines 1.5 to 2.5, which shows calculated on the mathematical model. And this is the vertical bore pile which has been put with a beam cap. From this point to this point is called as a lower part. This is the vertical bore pile which is there. This is the wall which is proposed to be constructed, which is well below the slip circle, and these are the sand piles which are proposed to be provided, which are provided to relieve the pore pressures within this zone. Further down, this is the sea, and these are the anchor blocks which are proposed to be provided for stop the erosion of the sea, such that this is the toe is such that the toe is also protected and all the materials are well within the slip circle.
This is the toe part of the unstable slope of this Cabo Hill, and it's a crucial part, and the slope forming material will be there, and we suggested the one retaining wall and a protection for seashore.
Upper slope area, they have suggested we should go in for grouting of the cladding wall and grouting of the disturbed samples to the 4.5 meters, and also they have suggested that a cable anchor should be drilled well into the hard surface which is available at the site at a depth of 17.2 to 22.5 meters. Initially the department took up, based on these details, the department took up the detailed designing of the cable anchors, the piles and the pile caps. First the department laid the base layer of the beam caps and then made a grid of columns and beams. The department did the designing and laying of the project and also worked out on a method how to tackle the situation, how to tackle the remedies so suggested. First we have proposed a grid of columns and beams at a spacing of 4 meters to center to have a four rows of cable anchors. Then we have 4 rows of cable anchors, one drilled at depth of 22.5 meters, other at 20 meters, other at 17.5 meters and other as 15 meters deep into the Doro crust. ITD cementation came into the was awarded. They started the work. Initially we started grouting the cladding wall so that whatever the fissures and gaps and cavities were there within the wall to consolidate it, and also to have a proper joint between the concrete and the behind Doro crust. And further we did further grouting up to 3 meters so that the disturbed sample due to distress over the years are consolidated and brought into proper shape, and also improve the mechanical properties of the soil bearing. And then further we took a third grouting stage at 4.5 meters so that the balance, all the materials within the slip circle have been consolidated and the mechanical properties such as C and phi values are improved. After which we have taken the core samples to find out how much depth the grout has travelled and what is the sample of the soil which is there, and analyze with the samples which are taken earlier to starting the work. Once we confirmed that there is improvement of the mechanical properties of the soil at a pressure of 5 kg per centimeter square and allowed the grout to flow through and through the body of the Doro crust until the point of reduction. Once we got the point of reduction, then we allow the grout to, we leave the grout for 2-3 days, again go for regrouting to see any other further grout or due to distress or drilling purpose is going in. And once it is confirmed, then we go for water tightness test, and we allow the water to go under pressure and see the water loss. If the water loss is within the permissible limit of 5 luzens, then the board is dried up and made ready for putting of the cable anchors. The cable anchors are prepared for lowering into the board holes after when it is ready, after the test of water test, and then the cable anchors are lowered, and first 3 meters of the lower portion of the anchor is grouted and left for 28 days for the grout to gain the strength. After the required strength of the particular cable anchor has developed, the cable is slowly stressed to the design stress of 35 tons plus 10% for stressing loss, keeping the 10% of stressing loss allowance. Then after stressing the cable is locked over a stress plate and kept for 28 days to check up the performance of the particular borehole. Then if there is a loss less than 10% of the stress so put on the cable, then the cable is taken for final grouting. During this process, we also keep several cable anchors ungrouted called as a load cell to check up its performance over a period of time of a month or 2. This gives us the whole control over the methodology and the effectiveness of the grouting so conducted. After doing all this process, now we are sure that the whole disturbed mass has been grouted properly and tied to the strong surface so prepared little away from the slip circle. With this, the upper slope of the cabo was stabilized, and further little down below in the upper slope we have taken inclined piles of 15 degrees to the horizontal all along the affected area to a depth of 20 meters, and we have lowered the MS pipes into the holes and then lowered steel cage and then routed those boards which actually prop up the whole slipped area or a distress area, and also divide the slip circle to a smaller segment such that the total mass slipping reduces. and this is capped by an RCC beam, so that all the inclined anchors which are at 2.5 meter to center in a staggered way act in one unit and have a strength to keep the whole mass intact. That is called the treatment of the middle slope. This is the lower slope which is little gradual, but however at certain places steep slopes are there which are unsafe and which are moving with a small disturbance. These have been stabilized by providing laterite boulder pitching, and some places we are given laterite boulder sausages so that we get a proper slope. And at the toe of the middle slope we have taken up a row of vertical bore piles which go below the slip circle in a row for a length of 240 meters at a spacing of 4 meters center to center, a depth of 15 meters. These piles have been cased with MS pipe, and then in that we have lowered RCC cage and then concreted it, and there is a beam cap which is given. This also acts to deteriorate or to stop the movement of the earth which is likely to come. Thereby the slip circle has been clearly cut into three phases: upper slope, middle slope and lower slope. That means because the continuity is cut, the movement of the slip circle is reduced and then it becomes more stable. Thirdly, we have gone down to the lower reaches of the lower slopes of the Cabo Hill. In the lower slope of the Cabo Hill, we have gone for construction of a retaining wall which goes well below the slip circle, stops the movement of the particles, the soil, due to the movement of water during the monsoons, and then this also goes below the slip circle, thereby avoiding any movement of the soil whatsoever. This acts as a toe to the whole mass, whole slip, and which has been divided, as I said in the earlier, by three parts. Thereby the total movement which is acting as a one unison has been broken. The piece by piece has been stabilized in the upper, in the middle and the lower, thereby making the whole structure stable. So here we also taken a precaution of giving sand piles at 4 meters center to center all through the length of 140 meters. Any hydrostatic pressure, any pore pressure which is developing, which is unable to dissipate itself, will dissipate the pressure to this, so that no pore pressure as such is developed anywhere in the disturbed place. The care has been also taken to provide V-folds on the cladding wall, so that whatever infiltration of the rainwater, because Goa is faced with the heavy rains, whatever infiltration of rainwater takes place is allowed to flow out, thereby total movement of the fine earth, the clay or any other material within the disturbed place has been taken care of, thereby making the hill stable. Now we will go down to the seaward side. Toe of the hill has been bashed by the monsoon, bashed by the Arabian Sea, and very huge waves come and hit the toe during the monsoons, which actually creates the eroding of the toe. That has been protected by providing armor blocks all through the length of weight of 4 tons, ranging from 2 tons to 4 tons. So these blocks cut the wave energy and do not reduce the erosion which is taking place at the toe of the slope. After carrying out all this process, we have taken massive measuring devices which have been installed in place. We have taken care of installing high sensitive inclinometers on the face, in the bottom, in the center of it. We have put crack recorders in place which gives us the cracks which are developing to a measuring of 0.01 mm. We have got settlement gauges which show any settlement which is taking place, and then we have got inclinometers which have been drilled and kept at a depth of 25 meters. Any movement of surface will be noticed by the officials.
This is the inclinometer location. We have 9 such inclinometers located at 3 different levels of the Raj Bhavan slopes. Now this comprises of a specially made plastic in which torpedo or a probe is inserted. It is inserted for the full depth. It gives us the profile at every meter of this tube, the displacement in two dimensions, from which we can work out the deviation, the cumulative deviation also, and this can be used for analysis. Now the data from the probe is then connected onto a data logger, which can be then processed using a computer to give us the results. This is a settlement gauge location. We have 9 such settlement gauges situated at 3 different levels at the Raj Bhavan slopes. Now this gauge is lowered to a depth up to a depth of 20 to 25 meters, and it helps us measure the vertical displacement of the land mass below this level. Right now I am standing on the pavement of Raj Bhavan, and this place there are a lot of surface cracks visible, and to measure the behavior of these surface cracks, we have inserted one crack meter right across the crack, and this meter is then embedded in concrete. The cable from the crack recorder is then connected to a vibrating wire indicator or the monitor, which instantly shows the reading in mm or any units, indicating the relative displacement of cracks on that day, and this can be compared to the reading which were previous to, and we can find the displacement if any. So this is how it works. This is very easy to handle, and any layman can also use this instrument. Moment you press it on, you get the date. Then again you have to press enter. You get the time when you are taking the reading. Then you have to feed in the channel number. Altogether we have six such locations on top of the Raj Bhavan pavement. Here this channel number is 3. I have to feed the channel number and I have to press enter, and instantly I get the reading in mm. The reading can be seen. This data can then be recorded manually, and the same can also be stored in a computer for further use.
This project has been completed for last 1.5 years, and it has been giving wonderful results, because earlier we are having cracks and whole slopes used to move, but presently we have seen that there has been stabilization in the area, and whatever measures have been envisaged, I think they are quite successful. We have tackled about 120 meters of the length, and we have to tackle another 80 meters more. So presently I am very much satisfied with whatever the measures have been taken, and I think we will go a long way in adopting such innovative techniques.
So all I can say right now is that it was a very professional execution of the whole stabilization job, which was taken up by WRD and GSI. And as on date, we have not seen any fresh cracks appearing, and even the cracks which are existing are not widening. In fact, twice we opened up the cracks also to see whether to check the quality of the work that was done. And I'm happy to state that as of now, I feel that the intent behind this whole work has been fulfilled, and we were able to achieve stabilization of this structure.
I, as a Deputy Director General, Operation Karnataka and Goa, Geological Survey of India, express my pleasure to say that Geological Survey of India as a premier organizations put from the Operation Karnataka and Goa their officers for this particular geotechnical project, which was a long-standing issue, to mitigate particular operations where the wholehearted effort has been put to achieve the desired objective. I have full confidence about my officers to say that in the future years also the Geological Survey of India extend its wholehearted support for the particular type of geotechnical work if so comes on the way, and I am sure that we will achieve our desired objective.
Sir, I am really very happy and overwhelmed at this juncture. In the beginning, that's in 2003 when we came over here, and this was really a very tough task. It was a challenging task, but we took it as a challenge and we have done to the best of our ability with our expertise and also experience working in different parts of the country, and we have submitted our expertise report on the basis of which our WRD friends have implemented the recommendations what we have suggested, and I have all the faith and I have all the confidence that whatever we have done here, that gives a fruitful result for the safety and the betterment of this Raj Bhavan Goa. On behalf of Geological Survey of India, I extend my sincere thanks for Government of Goa, especially His Excellency the Governor of Goa over here, to give a privilege to work here, and for the confidence, the greatest confidence you had on the Geological Survey of India at the time when you had in a crisis. We thank you very much for that, and also we look forward to extend our expertise, technological know-how in any of the problems Goa encounters in future. Thank you very much, sir.
The Cabo Raj Nivas is a legacy of the Portuguese time and is a pride for the independent India. It is located strategically on the estuaries of Mandu and Zuari on the headland. Because of its beautiful location, the Portuguese had built the seat of governance, which has continued after the independence in the Union Territory and also when the state was formed. But the strategic location of the place is also exposed to the three sides by the action of the sea, and in the monsoon period it gets very turbulent. Right from 1960s we had been facing that the structure of Rajnivas is under threat. In 2003 the problem aggravated and the state government thought that we would have to relocate the Raj Bhavan to some other place. But that would be a poor second option. The first option would be to develop and rehabilitate the structure in the site itself. It was at this junction that the Department of Water Resources contacted the Geological Survey of India, and I am happy to note that the Geological Survey of India did a marvelous work of doing an estimation for the soil and its substrata. The Geological Survey of India carried out the test hole drilling of the headland at strategic positions and came back with a report indicating the substrata of the soil. Based on the study done by them and in the partnership with the Water Resources Department of Goa, we developed and designed the concept of restoration of the slope and the saving of the Raj Bhavan. The 120-meter restoration work was carried out in record time and it costed nearly 6 crores of rupees to the government. This cost of 6 crore rupees to the government is nothing as compared to the priceless recovery which we have made in the form of Raj Bhavan. Based on the success of this model, we are now doing the second phase of the work, which covers from the western side towards the southern side, which saves the grotto and the Secretary to Governor's place. I am happy to note that the Department of Water Resources and the Geological Survey of India, with an excellent teamwork in a time-bound manner, they have done this quality work, which is a matter of pride for the department as well as of Geological Survey of India. It is a matter of great learning for the department also, because it was a new area and the department took the challenge and stood up to the occasion and carried out the work in a perfect manner.
We have a beautiful place called Cabo Raj Nivas, where His Excellency the Governor of Goa resides. Normally we call Cabo Raj Nivas or Governor's place of residence, where the Water Resource Department has taken up a challenging job we found that the place is subjected to soil erosion due to heavy waves from the Arabian Sea. And when my department approached the Geological Survey of India, under their guidance and under their instruction, we have designed and implemented a project called Stabilization of the slope, which is subject to the sea erosions. And I am happy and proud to see that my department has completed the project successfully with great expertise. I am proud to say again that we have proved that we have expertise in completing such a challenging job. And the design and scope of work is very important for us to show that the design given by the Geological Survey or design adopted by my department is completed successfully within a time period. And we have ensured that the people of Goa and His Excellency the Governor should satisfied with our work, and we learned that Governor, His Excellency, is also happy to see that the work is completed in all respect, satisfactory, and now I am on a camera to put it on the record that my department is capable of carrying out such a challenging jobs. And overall, in the state of Goa, we have another task called anti-sea erosion works. Government of India has given us a financial support to take up the soil erosion of our beautiful beaches. So that is our second task to complete, and we are confident that we will do our duties based on expertise, commitment and dedication to the state of Goa.
आमी सगळी रपण गोयताव रपण मारून निस्तें धरून संवसातून वयताव सांजेच्या वेळार बालभुरग्यांक बसोय भरताव घरा येवन पडपो जेवण सुसेगाद न्हिदताव मांडो गोंयचो आमी गोंयांत गाजयताव मांडो मुडोन नाचोन मुडान दीस रे सारताव मांडो गोंयचो आमी गोंयांत गाजयताव मांडो मुडोन नाचोन मुडान दीस रे सारताव शेतकामती आमी शेतांत वयताव शेतां फोडून मेरो काडून गामरेवार वयताव रातचे घरा येवन आमी भाकऱ्यो लाखयताव जेवणा वेळार हिल्लो